Last lesson we're going to take a look at is Law of Cosines. So we've learned for Law of Sines, you use that for 3 different types of triangles. Angle, side, angle, 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 side, 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 angle. But without making a sketch, we've done this a couple times. Can someone remind me, what do you look for in the table that tells you it's Law of Sines? Yep.
2 rows that are filled in next to each other.
Yeah, you look for a complete row. Okay, you have to have one full row. Well, look at this kind of problem. We're going to solve this in a little bit, not yet, but I just want you to look at it right now. Is there a full row in that table? No. So when you use Law of Sines, the only way that it works is if you plug in a partial row and a full row. You can't even use an empty row. Well, we don't have any empty rows, but all we have is partial rows everywhere. So if you pick 2 rows, let's say you pick the first 2, you're going to have 2 variables. That's no good. If you say, all right, let me try the last 2 rows, well, you're still going to have 2 variables. You can only have 1. And if you pick the first row and the last row, you still have 2 unknowns. You can't have 2 unknowns. You can only have 1. So the law of sines would not work for this kind of problem. And let's make a quick sketch. So this is A, this would be alpha, this is B, this is beta, this is C, and this is gamma. What kind of triangle is that if you were to describe it with 3 letters?
Is it side, angle, side?
Yeah, it's side, angle, side, SAS. Is that a type that we've studied on Monday and Tuesday? SAS. You think, Kate?
I don't think so.
No. We've done the angle, angle, side, angle, and side, side, angle. We haven't done side, angle, side. And the reason is you can't, the law of sines. So to solve a side, angle, side, or a side, side, side problem, you have to use law of cosines. Side, side, side would be the same issue, because imagine you knew A, you knew B, and you knew C. You wouldn't have a row that's full. Here's a sketch of a side angle side problem on the left and a side 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 problem on the right. If you think about it, there is one combination of letters missing, and that's angle, angle, angle. Well, that's impossible. You can't solve a triangle if you know all the angles. How come? Like, let's say I said to you, I'm thinking of an equilateral triangle. 60, 60, 60. Tell me how big each side is. I just told you all the angles. 60, 60, 60. Yep.
You can't solve it because the triangle would be scalable. No matter how big or small you scale it, the angles would stay the same.
Yep. So because when you only know angles, all you can do is find a triangle that's similar. And there's an infinite amount of them. You could have a triangle that's 5, 5, and 5. That's equilateral. You could also have 12, 12, and 12. Then you have to have at least one side. Always. At least one side. So when I write down the law of cosines, I'm going to use the same notation we've been using. A, B, and C will represent sides. Alpha, beta, and gamma will represent angles. And here's the first part of the law of cosines. It's not the whole thing, but does that look like any other formula? Alan? Yeah, it looks like Pythagorean theorem, and this formula is based on the Pythagorean theorem. Okay, we don't go through the proof in this class because it requires It requires what are called trig identities. We haven't learned those, so we can't, the proof wouldn't make sense if we tried to do it. So we're just gonna go with the formula. So it starts out like the Pythagorean theorem. C squared equals A squared plus B squared. And then you put a minus 2 times the two sides that just came before, A and B. And the last thing is you multiply by the cosine of the angle across from the letter you started with. So that is the law of cosines. So in general, think of it as a pattern. Don't try to remember the exact letters. One side squared equals the sum of the other two squared minus twice the other two that you just used times the cosine of the angle across from the letter you started with. So we could start with a C. We could also start with a B. Anyone have a guess what would be next if it follows the same pattern and I start with a B? Yeah?
A squared plus C squared.
So A squared plus C squared minus, what would come after that? Jason?
Negative 2AC.
Negative 2AC. Yep. And then the last thing would be, yep,
Cosine beta.
cosine beta. All right, and you could also do it starting with A squared. A squared equals B squared plus C squared minus 2BC cosine alpha. And I mean, we could write this 20 more ways. X squared equals Y squared plus Z squared minus 2YZ. You can write it whatever three letters you use. You can just keep writing it different ways. But the important thing is the pattern. Okay, so you want to remember the pattern. Especially for a word problem where maybe they use different labels than what you're used to. Because then that can start to throw people off if all they remember is exact letters. You want to remember the pattern. Any questions on the pattern? Now, we're not using this formula on right triangles. You could, but we're not. Okay, we've studied right triangles before, and I didn't teach you any of this when we did right triangles because you don't need it. But let's say you tried to use this formula on a right triangle. What does that mean your angle is? You have a 90. Well, watch what happens if you take a 90 and you fill it in for the angle, and you take the cosine of it. What did the cosine of 90 just come out to? 0. 0 times anything is what?
0.
Right. So if you plug in a 90, what basically happens is this whole thing turns into 0, and you're left with exactly the Pythagorean theorem. Right. So this little adjustment at the end, the minus part, is only there because the angle is not a 90. When this angle is not a 90, then this won't be 0, and you're going to need it. Right? So this is kind of like Pythagorean theorem, but useful on any triangle, not just a triangle with a 90. Basically what it is. What else? So the angles still have to add up to 180. But you can't use Pythagorean theorem like just the regular Pythagorean theorem. You want to stick with using this formula. Right, let's try it out. So A is 2, B is 3, and gamma is 60. All right, so now when we look at that right away, how can you tell if we should try to start this with law of sines or law of cosines? Yeah.
There isn't a full row filled in.
Okay, which would mean what?
It would be solved with law of cosine.
It's going to be solved with law of cosines. If it doesn't make sense looking at the table, why you need to use law of cosines, sketch it. I think I already sketched it. A is 2, alpha, B, beta, C, gamma. This is side, angle, side. Okay, when you have side angle side, the first thing you have to do is solve for the missing side. You can't do anything else right away. Go back and look at the formula. No matter what version of the law of cosines you use, every side is in every version. Every version has an A, a B, and a C somewhere. You're already missing the C. So that's one thing you're missing. You can't be missing anything else. So looking at the three versions, let's just call them 1, 2, and 3. What version do you think we would have to use in our problem? You know gamma, and you have to make use of that. So use the version that has the gamma. If you pick a different version, you're not going to use the gamma. Well, now that's something else you don't know. So we're going to do version 1. C squared, and I'm going to write it down. So C squared equals A squared plus B squared minus 2AB cosine gamma. Right, now we'll fill it in. Right, let's start with C. We don't know, so we're going to leave that alone. Let's go on to A. What's A in this case? Yep. 2. And what about when you square it? 4. B is 3. And when you square it, you get 9. Oops, now the next part is 2 times A times B. What's 2 times A? 4. What's 4 times 3? 12. So this is minus 12. Cosine. And now I need to look up what gamma is. 60. When you're doing a side angle side problem, the variable is already going to be by itself on the left. I mean, there is something we're going to have to do to get rid of this exponent of 2. But besides that, the variable is by itself, and all the numbers are on the other side. That's good. You want the variable pretty much by itself. Okay, if I follow order of operations, what would I do next? Well, you can go out of order a little bit, but you got to be careful because you can mess things up. Yep.
You would do 9 plus 4, which would be 13.
Yeah. So you get 13, and then what did you say to do next?
Subtract it from 12.
So do 13 minus 12.
No.
What if you had this, like 5 times 8 minus 4? Would you do 8 minus 4 first?
Wait. No.
No. You always want to do the multiplication before you do subtraction. All right, so 13 minus 12, we can't do that. We can do 12 times cosine 60, just like here, we could do 5 times 8. Any questions why we got to do the multiplication first? Okay. So we're going to have 13 minus, and let's type in cosine of 60. Well, the cosine of 60 is a half. This is 1/2. What's half of 12? 6. Now you can do 13 minus 6. That's fine. You get 7. And I have one step left to get C by itself. Yep.
You have to take the square root.
Yep, we'll take the square root. Up until this step, everything was exact. Now it's not, it's an approximation, so I'm going to change my symbol. Take the square root of 7, and that's the length of the side, 2.646. Okay. Any question on that? Now let's put that piece of information in our triangle. Yep.
I do have a question. My calculator has been only giving me up to the last 2 digits in the
Is the word fix lit up on your calculator?
It is.
So it's because it's rounding everything to a fixed amount of digits.
How do I make it not do that? Because I feel like it be a problem.
Let's take a look. I'll have to take a look, but it's in the settings.
Okay.
It's like on my calculator, I know I could go to mode, and then right here it says float, and then 0 through 9. If I put mine on 2, if I put it on 2, it would do the same thing yours is doing. So it is a setting. I mean, worst case, you can just reset the entire calculator,
Sure.
and then it'll put it back the way it was. Do you know how to reset it? I think you press on and clear at the same time. Did that say memory cleared?
Yes.
Yep, so now it should be fine, but try it and let me know what happens.
Okay.
Okay. Okay. Let's write down this side. 2.646. Besides being side angle side, can somebody tell me what other kind of problem it is now with this additional piece of information? Yep.
Side angle.
You could view it as a side angle. You have a side, and an angle, or side angle. There's a couple ways to look at that one. And it's one other type. Okay.
Side.
It is side. If you continue to view the problem as a side, or side angle side, we're going to finish with law of cosines. If you did it as side angle, you could try to finish this with law of sines. But I would avoid that because what don't we like about side angle? Yep.
You have to use something that wasn't given.
Well, we're still going to have to use something that wasn't given to do these other two. So either way you finish this problem, you're going to use stuff that wasn't given. But there's something really particular I don't like about side angle. Yep.
One zero no solution.
Right. If we get into that, now we have to start checking for the 0, 1, and 2 solution stuff. And I want to stay away from that because we can avoid it. So we're not going to view this as side angle. If you start a problem with law of cosines, my advice is finish it that way. Okay? Don't switch to law of sines. Can you? Yes. But you might get it wrong. So let's finish with law of cosines. Okay. So once you have all your sides, you can do anything you want. You can either find alpha or beta. Let's just do alpha. Okay, so to find alpha, how does the law of cosines start out that has alpha in it? What letter is at the beginning? A. So a squared, b squared, c squared, minus the 2bc, cosine alpha. Okay, now we'll fill it in. All right, so a squared, we got that, that's 4. B squared is 9. And now c squared, we don't have to take our answer for c, 2.646, and square it. We already have c squared. What is c squared? 7. We have that from the work we just did. If you take 2.646 and square it, you're probably going to get like 6.999. Well, it's 7. So let's just go with 7. Okay, that's about all I can do without a calculator. Now I need a calculator to do 2 times b times c. Well, 2 times b is 6. I need to do 6 times 2.646. Okay, so anyone with a calculator that can just type in 6 times 2.646.
What was it?
6 times 2.646. Because we're doing 2 times b times c. 15.876. All right. And up until this point, we haven't typed in any variables. Here's our variable. Cosine alpha. Okay. What could I do next on the right-hand side? Yep, add the what?
9 to 7.
Yep, you can add the 9 and the 7, that's fine. Now, you have to be careful at this step. What you have right here is basically, if you want to think of it as algebra 1, like this. You have 4 equals 16 minus 15 times a variable. That's what I've written right here in a simpler way. 4 equals 16 minus 15 times a variable. If you want to get the variable by itself, what would be your next step in this equation? Yep.
Subtract 16.
Subtract 16, and that's exactly what you have to do up here. You cannot do 16 minus 15. Those aren't like terms. And they're not like terms up here. Same reason. So bring the 16 to the other side. Like that's going to give me negative 12 equals negative 15.876 cosine. Right? And now we have two things left to get alpha by itself. You got to get rid of the negative 15 and the cosine. Always start with what's further away. How would you get rid of this negative 15 and put it on the other side? Yep. If it was like this, like if you had a plus in there, then I would say yes, you would add the negative 15 to both sides. But this is really multiplication. Yep.
You divide by 15.876.
Yes, we're going to divide by negative 15.876. Negative 15.876. That cancels all that out. If you want, you can cancel these negatives. Negative divided by negative is positive. Don't even do that. Just leave it. 12 divided by 15.876 equals cosine alpha. And what do you think my last step is now? Yep.
Inverse cos on both sides.
Yeah, we did inverse sine when we had to solve for an angle yesterday. Well, today it's inverse cosine. Now, before you type in the inverse cosine, just look at this fraction. If the bigger number isn't in the bottom, then just stop. You did something wrong. You're not going to get a no solution when you do this kind of problem. Okay? None of the law of cosines problems I give you on the test will have a no solution. If the bigger number was in the top, you would get a no solution. Okay? Should not happen. 15 is the bigger number. It's in the bottom. That's good. All right, let's type it in. All right, inverse cosine of 12 divided by 15.876. That's how you type it in, and that's what you got. That's going to round up. So it's going to be 40.900. If we want to do 3 decimal places, they're zeros. 40.900. So if the answer is supposed to be 40.9 and you got on the test like 40.8, that would be okay. If you got like 41.6, that's getting too far off. Especially if you're rounding to 3 decimal places, your answer shouldn't get messed up that much. All right. So at this point, we're done with law of cosines. Because what can I do now to get the third angle? Yep.
Subtract the 40 and the 60 degrees from 90.
Yeah, so subtract the 2 angles that you have, and that will give you the third one, 79.1. And that's a law of cosines problem where you had to find a side and an angle. Out of the 2 types we're going to look at, side angle side and side side side, I think this one is harder because you have to do one of each. One time you have to find a side, the other time you have to find an angle. In a side problem, you are never finding a side. All you have to do is find angles. So this problem is going to look more like this part right here. You're going to have to do this. You're not doing this. You're not finding a side. Now, at a minimum, how many times do you have to do law of cosines here?
2.
You have to do it at least 2 times. Now, the nice thing about side is a mistake in one part has no effect on anything else. If you did law of cosines 3 times, you can find all 3 of these completely separate. And a mistake will not mess up anything from another answer. If we only do it 2 times and we make a mistake, then we will carry that mistake into the third angle. But that's how we'll do it. We'll do it twice. We already did alpha, so let's practice the other ones we haven't done. Let's try like beta and gamma. Okay, so to find beta, let's write it down. Here's your formula. And fill it in. Okay, so Tyler, what's b squared?
Six.
How do you get that?
Wait, b squared? That's 9, sorry.
9. Yeah, don't listen to that person. B squared is 9. Now a squared, what's that? Yep.
16.
Yep, I like that. 16. And c squared? 30 what?
6.
Yep, 36. Minus 2 times a times c. Since these are all nice numbers, we really don't need a calculator until we start getting into decimals. 2 times a times c. Well, what's 2 times a?
8.
And what's 8 times 6?
48.
48. Perfect. Okay. How about Justice? Can you tell me what I would do next?
Combine like
Yep, we do have some like terms we can combine. And what do you get if you add 16 and 36?
52.
Yep, 52. Now the next step is where you want to be careful. This is where people sometimes mess up. What do you do next? Yeah.
Minus 52.
You got to minus the 52. You cannot do 52 minus 48. You can't do that. So minus 52. See what we get there. 9 minus 52 is negative 43. Okay. And let's see if we can do the last 2 steps in one step. All right. What are the last 2 things I need to do? Yeah, Caitlin?
Divide by negative 48.
Divide by negative 48. Okay.
Take the inverse cosine.
And take the inverse cosine. I'll cancel those negatives. Bigger number is in the bottom. It always should be. Perfect. Think of the bigger number. The bigger number is like heavier. If something's heavier, it'll sink to the bottom. So bigger number always goes in the bottom. Okay, inverse cosine of 43 over 48. That gives you 26.384. Technically, you could try law of sines at this point to finish it, but if you do that, you have to be very careful, and the chance of making a mistake is probably greater. All right, is there any question on how we would do this again to either get alpha or gamma? Anyone want to see it? See these steps one more time? Okay, so let's try a word problem. So this will be, I think, it's our last one. Yep. So like most word problems, you want to set up a diagram. The diagram here is going to be given to you. So what we have here is 2 points, A and B, and the surveyor wants to measure the distance between them. So you might just think, well, just go, they measure the distance between them. Well, the problem is maybe these 2 points are on like opposite sides of the canyon. You know, you're standing on one side of the canyon, and you look over there, and you see the edge, and you look over there, and you see the other edge, and you want to know how far apart it is, because you're planning the motorcycle jump, so you got to know how far it is. All right. So I'll show you the diagram, but basically you're standing at point C, and points A and B are in front of you. So the angle from where you are to the 2 points is 70 degrees. And you know the distance from where you are to point A and from where you are to point B. So in this case, we don't have a canyon, we have a house. And we want to know the distance from here to here. And we don't feel like trying to measure around the house. We just want to know what the distance is straight across. And you're standing here. Well, this distance is very easy to measure. And so is this distance. You can just walk right to those 2 points. And this angle is the 70 degrees. So the distance to point A is 50 feet, and the distance to point B is 70 feet. Basically, we've got something like this. Your goal is to figure out the length of that dotted line. So how far apart are the houses? Or how far apart are the, I'll just say it like this. How far apart are points A and B? Now, normally I would say, if I really wanted to do this, I would just measure, from here, and then measure across the front of the house, and then just measure over here. And then just add it all up, and you get the distance between the 2 points. But the problem is, we don't want to get anywhere in this zone. We don't want it. We call this the danger zone, right, where that circle is. And the reason it's kind of a dangerous zone is there's creatures in that zone we got to stay away from. So here's what we got going on. First of all, we've got poisonous tree frogs. So you get over there and then they spit on you, whatever they do, you're poisoned. The other thing we have is giant spider crabs. Those things, they're huge. It can be up to like 7 feet. You don't want to get anywhere near them. And then we have the Easter bunny. So we don't want to go in between the houses. Okay. So we want to figure out what the distance is, but we want to stay away from all those things. So we're going to stand at the bottom. Now, I know it says a surveyor is measuring the distance. I didn't have a picture of a surveyor, but what I did have was a World War II soldier. That's my soldier. So the soldier, he's probably pretty well armed. He might be able to take the Easter bunny, but again, I don't know. The Easter bunny looks like it's actually taller than him, so probably stay away from that. So let's fill in our lines here. We've got that distance, and the goal is to find that distance. Okay, what did it say that angle ACB was in the problem? Yep, 70. And what was the distance from A to C? 50, and that's okay. We can measure that because we're staying far away from those creatures, so we can measure that over here. And what about the distance the other way?
70.
That was 70. Okay. So this is a side angle side triangle, and we're solving for the third side. Let's call it x. So the law of cosines is going to start out x squared equals. And then anyone think they can tell me, whoops, that's feet. What would come next?
Squared.
50 squared, yep.
70 squared.
Plus 70 squared, okay.
Minus 250, 70.
250, 70.
Cosine. Would it be the cosine of 70 degrees?
And then the cosine of 70 degrees. Yep. Okay, so let's solve for x and see what the distance is between the houses. All right, what's 50 squared? How much is that? $2,500. What about 70 squared? 4,900. All right. 2 times 50 is 100. And what's 100 times 70? 70 hundreds, yeah, or 7,000. So minus 7,000 cosine 70. So we're able to do a little bit without a calculator. I think we can do a little more. What's 2,500 plus 4,900? Yep, so that's 7,400 minus 7,000 cosine 70. I'm just going to leave that like that. All I want to do now is get rid of this exponent of 2. How do we get rid of that exponent? Find the square root. So I'm just going to type all of this in at once. Forgot my 0 on the 7,000, but I just fixed it. And doing it this way is the best way to do it because we haven't rounded anything. The more you use the calculator and round in the problem, the less accurate the answer starts to get. So, square root of 7,400 minus 7,000 cosine 70. Okay, and calculator should handle order of operations, no problem on that. So distance between the two houses, 70 point, we'll say 76. 70.76. That's the distance between A and B. That's it. Any question on how we got the distance between the 2 points? All right. So the homework for tonight, it's on law of cosines. And it's 274, 9, 11, 13, 17, 25, and 27. Six questions. We'll go over that tomorrow, and then after we do that, you'll have the rest of the time if you want to make a reference sheet, or you can work on the review worksheet that I have on Schoology.